So hello guys, welcome back to Gettobyte platform once again. I hope you all are doing well and are working great. So continuing with the series of sensors and module interfacing with host microcontrollers, in this video we are going to we are going to explore the RFID technology, and we are going to interface new module RFID module MFRC522 with our host microcontroller. So before proceeding with this thing, I want to give in one very important update that lately I've been working a lot on my Gettobyte website, where I'm making a blog kind of tutorials and format on the various topics of embedded firmware development, embedded systems, microcontrollers, automotive, and various technical content. So you can check out the website and you can find various blog content on embedded basics, embedded microcontrollers, sensors and module interfacing, RTOS and IoT, and many other things related to the technology, different explaining different kind of technologies. So do check out the website and do give me its feedback, and anyone who want to contribute with the content on making on this, they can definitely reach out to me. Now coming back to the main topic of our video, in this video we are going to interface RFID module MFRC522, which comes under the RFID technology. I have explained in last couple of my videos about RFID technology in a very animated and an interesting way. Also, viewers can check out this blog on RFID technology, which I have written on Gettobyte website, explaining various things about the applications of RFID technology. How does RFID technology actually work, core working principle, some international, this is the standard which RFID technology follows, what all systems does RFID technology consists of, and various things. So you can check out this blog also to get an in-depth idea about RFID technology. Now in this video we are going to work and understand about the this module MFRC522, which is designed and manufactured by the NXP semiconductors. Now in this video we are first going to understand about the MFRC522 features, specifications, what all does this IC and this module consists of, and then in the next video we are going to make its driver, and I am going to make you understand about its functional description, APIs, its state machines, and how to write its driver in C++ code so as to interface this module with any kind of microcontroller. So now, without wasting time, let's get started. So first thing that we need for interfacing any sensor or module is we are going to understand its data sheet. So MFRC522 is an integrated circuit for contactless communication at 13.56 MHz. This contactless communication here is RFID technology. So as to know about RFID readers, what are RFID readers and what are RFID tags, I would recommend that viewers should watch above video so as to get a understanding, get a clear understanding on it. Now MFRC522 reader supports ISO14443 protocol and MI frame and N tag. Now what does this statement means is basically ISO/IC1443 is a standard, is a kind of RFID protocol by which RFID readers and RFID tags communicate with each other. So MFRC supports that protocol and MI frame and N tag. So as I have told, MFRC522 is designed and manufactured by NXP semiconductors. Okay, and NXP semiconductors not only manufacture the RFID readers, but it also manufactures and designs the RFID tags. And NXP semiconductors have named its tag a family, that is the MI Fair family is the NXP RFID tags. So it says that this statement means that MFRC522 supports ISO14443 protocol. Also it supports the MI Fair/N tag based RFID tags which MFRC reader is going to scan. Now MFRC522 has number of things inside it. Okay, so it has, now coming to these features, MFRC522 supports ISA14443 and MIFA/NTAG based RFID readers. It has highly integrated analog circuitry to demodulate and decode responses. What does it mean is, as I have told, and MFRC522 is a contactless communication module, RFID module. Okay, so it will be doing an wireless communication, and for that wireless communication we would be needing an analog circuitry so as to decode whatever data we are transmitting wirelessly, and we are getting data wirelessly, so that we can decode that data. So it is highly integrated analog circuitry for demodulating and decoding the responses from the RFID tags. It also has buffered output drivers for connecting an antenna. Of course, we would be needing an antenna whenever there is some wireless communication. So it also has an antenna with the buffered output feature. Puts three types of RFID readers. Okay, MF1XS20, MF1XS70, and MF1SX750. So this module can only detect these three tags. And normally when we buy this module, we get the RFID tags alongside with this module in its packaging, and those are the tags which are based upon these three only. Okay, and it supports high ISO14443 protocol. As I have told, that it's an international standard and a protocol by which RFID technology, RFID modules and readers communicate with each other. Okay, RFID readers and tags, and it supports, like, RFID reader would be connected to our host microcontroller. So now by what way would our RFID modules would be connected? This MFRC522 would be connected to our host microcontroller. So that is basically depends upon SPI I2C, or we can also connect it via RS232 serial UART protocol. Okay, we are going to use in our demo and in our tutorial purposes the SPI communication. Okay, so we are going to connect this modules SPI pins with our host microcontrollers SPI pins. It also has a FIFO buffer for handling of data which is being transmitted from an RFID tag, from an RFID reader to the RFID tag, or the data which we get from the RFID tag or to the RFID reader. So all that transmission and receiving is being handled on the FIFO buffer, which can handle about 64 bytes of data at a time. It also has an interrupt mode. It also has programmable software mode, and we can program the timers in it so as to configure at what clock we need to drive it. It has internal oscillator for generating the timer peripheral, for supporting the timer peripheral and generating the signals for timer and the work for the communication of this module. And it has also a CRC coprocessor. CRC is cyclic redundancy check. So now why does we need a CRC coprocessor? Because as I have told you, this module is used for wireless communication, contactless communication. So we would be needing some kind of security so that we can check, okay, the wireless communication is authenticated or integrated. Okay, so for that, CRC coprocessor is also inbuilt on this, and it has programmable input and output pins so as to get the host microcontroller triggered that some interrupt is being occurred. Okay, so for now, like the video, subscribe the channel, and press the bell icon to get notified for new videos, and share it with your friends.